Okay, class, this is page 4 of your section 4.1 part 1 lecture handout. In this example, we do an application of the complementary angle theorem that we talked about on the previous page. And you're asked to find the exact value of sine 62 degrees minus cosine 28 degrees. Well, the first thing you want to notice is that 62 degrees and 28 degrees are complementary angles because they add to 90 degrees. So it looks like we might be able to apply the complementary angle theorem in determining what the value of this trigonometric expression is. Well, from the previous page, since these are complementary angles, the sine of 62 degrees has to equal the cosine of 28 degrees. And you can verify that with your calculator. Make sure it's in degree mode. The sine of 62 degrees to 4 decimal places is equal to 0.8829, which is the same for cosine. So it is indeed true that sine of 62 degrees is equal to cosine of 28 degrees. So these two are equal. And so you know from algebra, if I subtract a quantity from one side, I got to subtract it from the other side. So I'm going to subtract cosine 28 degrees from both sides. And on the left, I have sine 62 degrees minus cosine 28 degrees. And on the right, I have cosine 28 degrees minus cosine 28 degrees. Right? You can see where I subtracted cosine 28 degrees from both sides. Well, anything minus itself is equal to 0. Just like 5 minus 5 is 0, 10 minus 10 is 0, cosine of 28 degrees minus cosine 28 degrees is equal to 0. So this on the right hand side is equal to 0, and we have sine 62 degrees minus cosine 28 degrees is equal to 0, and so that's the answer to our problem up here. That's what we're trying to find. What's the value of this trigonometric expression equal to? Well, it's equal to 0.